Okay, we're going to create a couple of sets of composites. One we're going to create for our block model, and then we're going to go and create a couple other sets just for illustration purposes. When using Genesis, we create our composites with a set of mineralized intervals. So the active set of mineralized intervals will determine the composites that are created. If you recall earlier, here is where I had my envelope created. So we can create a set of composites based on these mineralized intervals. But before we do that, I'm just going to go and switch the sets, say, to this one. Remember, we created a mineralized interval based on entire holes. And we're going to go and make a couple of practice composite sets. So in the composites panel here, we can see it starts off as default. There's nothing in default. We could import if we had another project or we were updating a project. We could import in the composites from a previous project. We can export them if we had them to export. We can create them. We can delete a set, or we can add a set. So before we create any composites, let's add a set. And we're going to add a blank set. And we're going to call this one test. And with our test, we're going to use our mineralized interval copper 2, and we're going to create a couple of different methods. We're going to create composites using different methods. So let's look at the first one, central. If you click on the mode, it'll give you a little rundown of what you can do. So central says we'll create one composite in the center of each interval. So for each mineralized interval we have here on the screen, we'll create one composite with a center on the center of the mineralized interval. This is not particularly useful for block modeling. However, it can be used for polygonal estimation. Also, it may give you a good idea of the length of your mineralized intervals, the grade of your mineralized intervals, and the centers. So if you wanted a quick rundown, then it might be a good composite set to create. So let's try that first. We'll click OK. Warning, all composites will be deleted. Do you want to continue? We're going to click yes because we don't have any composites to delete. And we created 92 composites. If you recall, we had 92 holes, we have 92 mineralized intervals, and that's what we have. We could export it and we could determine the lengths, the grades, and the centers of each of these intervals. Okay, so let's go to the next one. Regular. Regular is the normal method for creating composites. It's based on the length. There's a few criteria here. The minimum sample length is the length that will cover if there's gaps between mineralized intervals. And we have another one here, minimal interval lengths. If we click on that, it's the minimum interval length for creating the composite at the ends of intervals. So let's picture in our mind that we had let's change this here to 3. So we have a 10-meter mineralized interval, and we want to chop it into 3-meter composites. We're going to get 3 even, but then we're going to have 1 meter dangling. What are we going to do with that 1 meter? If we set this to 1, it's going to say, okay, let's create 1 extra 1 meter composite. And depending on the settings, you could either have none created with that dangler because it's too small, or you could have that extra created because it's big enough to make that extra. So if we had, say, 9.5 meters with this minimum interval length of 1, we would chop that 0.5 meters and it gets lost. If we go back up to minimum sample length here, 0, we have dilution on. And let's take a look at that. So if we go over to options, data constraints, dilution, give gaps default values, and we can select or deselect that. Okay, so what is our default values? If you recall earlier in our schema and colors, we have our copper variable here, and it has a default value of 0. So in the dilution, we're going to give the blank information, default values of 0. We are going to go back and we're going to do the same thing here, and we're going to create that. Continue. We have 10,311 composites created. Let's see what other types of composites we can do. We can go by bench. Now, in this one here, you'll notice if we click on mode, we can see by bench creates composites for each bench of the default grid. So before we create this, which we're not actually going to create this, we'll just talk about it, but let's go see what the default grid is. So if we went to our options, data, default block grids, we can see here is our block grid origin information, here is our block sizes, so our X, Y, Z direction, the discretization, etc., etc. So we'll create our composites on benches based on the information here. When you import your drill hole database in, Genesis will create, auto-create this information, and you will have to come in and edit it to make it how you would like it. If you would like to see where your extents of your block model is, there it is with the white box here. Okay, so you could create them on benches. Calculated length. Calculated length is similar to the regular, however, this time you only choose the length of your interval and you choose a rounding type. So the length of your interval is the same, but the rounding type is going to determine how many you have. So if we had an example here, they chose 25 meter interval, and they wanted a composite length of 10. They divide the 25 by 10, and you could have 2.5 composites. So you could either have 2 composites of 12.5 meters or 3 composites of 8.3 meters. It will distribute the length of the composites along the mineralized interval if it's not perfectly divisible. Depending on the rounding type you choose, round up will take the highest number of composites possible, round down will take the lowest, and round closest will take the best choice of the two. And lastly, we have original sample. It makes composite centers for each assay. Let's take an example of that. Continue, we'll overwrite everything. And we created 1,605 samples.